Friends, let us continue to discuss about the failure theories more in detail in this lecture. So, we have discussed about 4 failure theories so far. Okay? We will now discuss the 5th theory, which is the maximum distortion theory. This theory was proposed by von Mises and Henke, and famously also known as von Mises theory. The statement of the theory is as follows: inelastic action or yielding at any point or cross section in a member occurs under combination of stresses. This begins only when the strain energy per unit volume absorbed at a section is equal to the strain energy per unit volume corresponding to the yield point stress obtained from the stress strain curve of simple tension test. The statement looks similar to what we have in the strain energy theory, but there is a marginal variation in this theory which we will explain as we proceed. So, for a triaxial stress state, we already wrote this equation: total strain energy per unit volume, which is given by U, is expressed as follows: we call the equation number 1. Neglecting the higher powers, one can also write the volumetric strain as follows: the volumetric strain is given as a sum of the strains in all the 3 axes, neglecting the higher powers, where the strain in all the 3 axes are known to us earlier as I am writing now. call this equation number 3. I can substitute 3 into and let us see what do we get. So, we get the volumetric strain as 1 by E of sigma 1, 2 and 3 minus mu of two sigma 1, 2 sigma 2, 2 sigma 3, which can be said as 1 minus 2 mu by E sigma 1, 2 and 3. This is EV. We call this equation number 4. Look at this equation carefully. This equation 4 states that volumetric strain is proportional to the sum of 3 principal stresses. If the summation is 0, then volumetric strain vanishes, correct? So, if the volumetric strain vanishes, what happens to the member or the body? Only the body or the member will be subjected to distortion, so friends, the total strain energy of a member or a body consists of two parts. One, the one which is associated with volumetric change of the body, the one which is due to change in the shape of the body. Which we call as distortion. Therefore, for the condition of 0 change in volume, we get sigma 1 plus sigma 2 plus sigma 3 as 0. Now, if these stresses are equal to magnitude P, then there will be no distortion in the body, because the stresses are equal in magnitude and direction. So, no volumetric change and no distortion. Hence, P should be sigma 1, 2 and 3 divided by 3. Let us explain this graphically. If we have a body subjected to triaxial stress state let us say this figure 1. This can be expressed as plus so sigma 1 is equal to the following relationship holds good. I call this equation number 7. Now, adding sigma 1 plus sigma 2 plus sigma 3 is 3p plus these variables. So, for no distortion case, P should be equal to this relationship. Hence, sigma 1, 2 and 3 dash should be 0, is it not? For no distortion case. Hence, the condition given in figure 3 that is this condition given in figure 3 causes only distortion and no change in volume. Okay? Is this agreed? Then further, let us say the stress intensities are equal. Substitute this condition in the total strain energy equation. Where is the total strain energy equation? This is equation 1, is it not? So, let us substitute this in equation 1, which says you will be now 1 by 2 E of sigma 1 square, 2 square and 3 square minus 2 mu of the products. Which now becomes 3 p square by 2 E of 1 minus 2 mu. We will call this as equation 9 because 8 is somewhere here, I suppose. Yeah. Okay. Since P is sum of these expressed by this equation, U volumetric will be now 1 minus 2 mu by 6 E of sigma 1, 2 and 3 the whole square. Am I right? Distortion energy can be obtained by subtracting equation 10 from the total strain energy, because total strain is summation of volume plus distortion, is it not, which is now given by equation 9. So, I should say U distortion should be total U minus U volume. Okay, let us do that. So, let us write down that U distortion will be 1 by 2 E of 1 square, 2 square, 3 square minus 2 mu of the products minus 1 minus 2 mu by 6E, let us say 2 mu by 6E of sigma 1, 2 and 3 the whole square, am I right? So, let us do a simple mathematics here. A plus B plus C the whole square is given as A square, B square, C square plus twice of AB, BC and C. Hence, sigma 1, 2 and 3 the whole square will become 1 square, 2 and 3 square plus twice of 1, 2, 2, 3 and 3, 1. Am I right? So, let us substitute this in the previous expression. So, now U distortion will be 1 by 2 E minus 1 by 6 E okay. Let us simplify this, which will be 1 by 2 E of minus 1 by 6 E of plus 2 mu by 6 E of okay, which will become sigma 1 square, 2 square and 3 square. Let us take it common and see what happens. If I take this terms common, then I can say, which will be 1 by 2 E, which is this term, minus 1 by 6 E, which is this term, plus 2 mu by 6 E, which is this term, is it not? Then we can also the remaining terms minus 1 by 3 E of sigma 1, sigma 2, 3 and 3 1. Where this term coming from? This term comes from this, okay, because twice 6e, so 1 by 3, correct, plus mu by 6e of, I can say here I get only mu by 6e, where I also have mu by 2e here, because mu by e, because this 2 and this 2 goes away, so mu by e, so I can now say it is going to be 6 times of sigma 1, sigma 2, sigma 2, sigma 3, sigma 3, sigma 1, that is these terms all are negative, okay. Because you see they are all negative. Plus I have this term also, so there is 2 and 2, 4 here, so I should say plus 4 okay. Let us simplify this. So which I do that, I will get 2 plus 2 mu by 6e of squares minus 1 by 3e of products minus 2 mu by 6e of products. Okay. Let us simplify this further, which will become minus sigma 1, sigma 2, 2, 3 and 3, 1 of 1 by 3e plus 2 mu by 6e. Is it not? See here, 1 by 3e, 2 mu by 6e. Both are negative. So, take a negative here. I further simplify this. I get 1 plus mu by 6e of the squares plus 2 into 1 plus mu by 6e of minus products, which says 1 plus mu by 6e of plus 1 plus mu by 3 of okay. I can further simplify this, which will now become 1 plus mu by 3 of the squares minus, I think I will get here, let me make this correction, I will get here 3, say, please make that correction. So, I get here 3 because 2 times of 1 plus mu by 6e becomes 1 plus mu by 3e, okay. So, 3. So, I take 1 plus mu by 3 as common, so sigma 1 square minus the products. my U distortion is actually equal to one plus mu by 3e of 1 square, 2 square and 3 square minus the products. Okay. So, let us do little bit more mathematics in this. Now, sigma 1 minus sigma 2 the whole square is this way, the whole square is this way, okay. Let us sum them up, which will be equal to twice of sigma 1 square, 2 square and 3 square, okay, minus the products. Is it not? What I can say now is sigma 1 minus sigma 2 the whole square plus sigma 2 minus sigma 3 the whole square plus 3 minus 1 the whole square by 2 should be equal to sigma 1 square, 2 square, 3 square minus sigma 1, sigma 2, 2, 3 and 3, 1. Am I right? So, what I have it here? So, I am going to replace this bracket term with this. Okay. So, there is 1 plus mu by 3e, there is 2 here. So, I can now write 1 plus mu by 3e of this will now become 1 plus mu by 6e of sigma 1 minus sigma 2 the whole square am I right? So, therefore, friends, U distortion is given by this equation. Now, the equation number will be, you can say 11, okay, let us say 11, will be given by 1 plus mu by 6e of this equation, right. Now, having said this, distortion energy for material under uniaxial stress state in a simple tension test is given by the following expression. So, in an uniaxial stress state, sigma 2 and sigma 3 will be set to 0 and sigma 1 will reach sigma yp, is it not? Hence, U distortion at yield point will be 1 plus mu by 6e of sigma yp square, am I right? Simply substituting this expression and make sigma 2 and sigma 3 0, you get this, is it not? We call this equation number 12, right. For yielding condition, according to this theory, in a biaxial stress state, where sigma 3 will be set to 0, sigma 1 minus sigma 2 the whole square plus sigma 2 minus sigma 3 the whole square plus 3 minus sigma 1 the whole square should be equal to 2 sigma yp square, isn't it? How do you get this? It is very simple. This is 1 plus mu by 6e here and this is 1 plus mu by 6e, okay. Oh, this is going to be 3, I am sorry, okay, this is going to be 3. So, I can now straight away say equating this with the previous case. So, I can write this equation, no? I can write this equation, no? 2yp square, okay. So, sigma 1 minus sigma 2 the whole square, p the whole square, sigma 3 the whole square is 2 sigma yp square. For sigma 3 equals 0, sigma 1 minus sigma 2 the whole square plus sigma 2 the square plus sigma 1 square should be equal to 2 sigma yp square. So, for a plane stress problem, sigma 3 is 0. So, sigma 1 square plus sigma 2 square minus sigma 1 sigma 2, okay, should be equal to sigma yp square. Am I right? Again, if you look at this equation, equation 14 also represents an ellipse. Let us try to plot this envelope. Let us say we get sigma yp in all the cases. I will mark that as an envelope for our control line. So, these are all sigma yp, yp and minus sigma yp, okay. So, for mu equals 1 by 3 and sigma 1 equals sigma, sigma 2 equals minus sigma, you will find the sigma value will become sigma yp by root 3 when you substitute in this equation. Okay. Now, let us draw the envelope, which is going to be, these are the points, it must touch here, okay. This is the envelope. So, this value sigma yp by root 3, whereas these values are sigma yp, okay. So, this theory has a good agreement with the experimental results. For ductile material. Further, if one of the principal stresses at a point is very large compared to others, then all theories lead to same results. That is very interesting. This is a graphical comparison of all the theories as we just now derived and plotted in these previous 3 lectures. So, in this plot sigma 3 is taken as 0. So, we are plotting for a biaxial stress state. So, all theories are there: maximum principal stress theory, maximum strain theory, total strain energy theory, von Mises and maximum shear stress theory. Okay, this is the plot what you have obtained. Please turn back your notes and compare them. This is what we are getting. We can write down some important observations for this. When we compare Sen-Venon's theory with maximum principal stress theory, it is seen that since tension is in one direction, reduce a strain in the other one, in the perpendicular direction, two equal magnitude tension will cause yielding at much higher values. We can compare this 0.5 and 0.1. 0.5 is here, 0.1 is here. When you have got both stresses as tensile, you will see that yielding is caused at much higher stress exceeding sigma yp, is it not? So, stress exceeds sigma yp to cause failure. If I say failure is at yielding, then this stress is exceeding sigma yp to cause yielding, is it not? In case of unlike stresses, maximum strain theory indicates yielding at 0.7 and 8. 7 is here and 8 is here. The values are equal to sigma yp of 1 plus mu. These values are much lesser than 0.2 and 0.4, is it not? This is 2 and 4. So, it means in quadrants 2 and 4, there is a very strong disagreement. What are these quadrants 2 and 4? When the stresses are dissimilar in nature of the same magnitude, the disagreement between the theories are very large. Maximum shear stress theory, that is given by Tresca, which is indicated by this color, is it not? Is indicated by an hexagon, irregular hexagon. Coincides with the principal stress theory in case of similar stresses. In case of dissimilar stresses, it shows disagreement. Okay. Maximum shear stress theory has only a very small deviation with maximum distortion theory. Maximum distortion theory is this, the purple line. Let us look into quadrants 2 and 4. The maximum shear stress theory is in Keown line. Okay. It has got a very marginal disagreement, is it not? It has got a very marginal disagreement. So, friends, if I really wanted to find out what would be my stress at failure, and if I believe yielding is one of the failure modes, and I want to estimate the stress at yield under a different stress state conditions and different stress magnitudes, different theories give me disagremented and non-proportional results. So, it is very difficult for an engineer to predict what would be my deciding stress value, because certain theories say stress can be even more than sigma yp to cause failure. Certain theories in certain quadrants say stress is definitely lesser than sigma yp to cause failure. It means even at lesser stresses than sigma yp, failure can be caused. So, for causing a failure, stress need not be equal to yield value. So, that is what we have learned by comparing these theories and assessing failure. Let us quickly do a problem and understand this more in detail. The major principal stress let us say sigma 1 of a member is 200 Newton per mm square tensile. The minor principal stress seems to be compressive. Okay. If the yield strength of the material is 300 Newton per mm square, find the minor principal stress using the following theories. Maximum strain theory, which is Sen-Venant's theory, maximum shear stress theory, which is called a stress cost theory, using total strain energy theory, also using maximum distortion energy theory. We can take mu as 0.25 for the problem. Let us solve this problem. For maximum strain theory, the governing equation is sigma 1 minus mu sigma 2 is sigma yp. Please check the derivation what we did. In this case, sigma 2 is compressive, so we taken as negative. Okay. So, sigma 1 minus mu of minus sigma 2 is sigma yp. So, sigma 1 plus mu sigma 2 is sigma yp. So, sigma 1 is known and mu is known, sigma 2 is not known and sigma yp is known. I can solve this to get sigma 2 as 400 compressive. okay, when I use this first theory. For maximum shear stress theory, the governing equation is sigma 1 minus sigma 2 is sigma yp. So, for sigma 2 compressive, sigma 1 minus of minus sigma 2 is sigma yp. So, 200 plus sigma 2 is 300. So, sigma 2 is 100 Newton per mm square compressive. Okay. For total strain energy theory, this is 2. The governing equation is sigma 1 square 2 square minus 2 mu sigma 1 sigma 2 is sigma yp square. Please check the governing equation. For sigma 2 compressive, this equation now becomes sigma 1 square minus sigma 2 the whole square minus 2 mu of sigma 1 minus sigma 2 is sigma yp square, which is sigma 1 square, sigma 2 square, okay, plus two mu sigma 1 sigma 2 is sigma yp square. So, 200 square plus sigma 2 square plus 2 of 0.25 of 200 of sigma 2 is 300 square. So, this becomes a quadratic in sigma 2. You can solve this quadratic and you find sigma 2 as 179.13 Newton per mm square compressive. Now, for maximum distortion theory, the equation is given by for sigma 2 compressive, so let us substitute that. Again it is a quadratic in sigma 2, solve, we get sigma 2 as 144.95 Newton per mm square compressive. So, friends, you see different theories estimate different principal stresses, is it not? So, that is the whole analogy what we learned from this theory. So, in this lecture we learned more about failure theories. We also understood a comparison between the failure theories and noticed a major discrepancy in 2 and 4th quadrants, correct. We have also learnt the stress need to be more than sigma yp to cause failure by yielding. That is what one of the theory says. All the theory says stress even at less than sigma yp can cause failure in quadrants 2 and 4, is it not? Which is not acceptable, because if I take yielding as a failure criteria, no stress lesser than yielding can cause me failure. So, it is very interesting that we have to fix up the stress at which the failure is initiated, then only we can start proceeding that as a landmark for design. So, that is a very interesting argument which we had in this couple of lectures and learned how different failure theories give us different understanding of failure modes between fracture and yielding, that is for ductile unbrittle materials. Thank you very much. Have a good day. Bye.